All right, so here are the notes for solving trigonometric equations. So our inverse trig functions can be used to solve equations involving sine, cosine, and tangent. However, first we need to isolate the trig function on one side of the equation, and then we use the inverse function to find the value. So remember, inverses are just undo things, so multiplication and division. So if I have 2 times x, the inverse is division, so I divide both sides by 2 to undo it. So the inverse sine, inverse cosine, inverse tangent undo the trig functions, essentially move it across the equal sign. And then we'll have to use stuff from the previous section, inverse trig function notes, to convert that reference angle back into the actual value. So find all angles 0 to 360 that satisfy the following equations to nearest tenth of a degree. So the first thing I need to do is get all my trig functions on one side and all my numbers on the other side. So I'm going to move all my trig functions to the left, all my numbers to the right. So this 3 sine x needs to move to the left, so that's -4 sine x minus 4 equals -5. And let's see here. So you'd have to add 4 to both sides. So -4 sine x equals -1. And we could do those 2 steps at once if you wanted to, and then divide by -4. So we would have sine x equals 1/4. So then when we solve, we use the inverse function of the absolute value of our ratio. So 1/4 is already positive, so doing the absolute value doesn't do anything. So the inverse sine of 1/4 comes out to be 14.5 degrees. So remember, that's my reference angle. So I need to find the actual 2 angles. So sine and positive means I have to be in quadrant 1 or quadrant 2. In quadrant 1, the angle is the same thing as my reference angle, so 100 or 14.5 degrees. And in quadrant 2, it's 180 minus my reference angle. So 180 minus 14.5. So 165.5 degrees. So these would be the 2 angles that would work in that equation. All right, so for 2, I've only got 1 trig function, so I'm going to leave it here on the left. So I need to move the root 3 to the right-hand side. So 2 sine x equals root 3. Divide both sides by 2. So sine x equals root 3 over 2. So now to solve, I use the inverse function of the absolute value. Well, that's still positive. And then this would give me 60 degrees. So sine is positive. So the original thing was positive. So once again, that's quadrants 1 and 2. So in quadrant 1, it is my reference angle. In quadrant 2, it's 180 minus my reference angle, or 120 degrees. So those 2 angles satisfy the equation. All right, so keeping going. So for this guy, I've got to move the root 52 across. So 8 cosine equals negative root 52. Oops, I forgot my x. Divide both sides by 8. So cosine x equals negative root 52 over 8. So when I go to solve for x, I use my inverse trig function on the positive value, so I ignore my negative sign, because it's always the absolute value. So the inverse cosine of the square root of 52 divided by 8 is 25.7 degrees. But remember, that is my reference angle. So for cosine and negative, I have to be in either quadrant 2 or quadrant 3. So for quadrant 2, the rule is 180 minus my value, and in quadrant 3, it's 180 plus my value. It's 180 minus 25.7, 154.3 degrees, and 180 plus 25.7, whoops, is 205.7 degrees. So either of these 2 angles will work in my equation. And always, if you want to check, you can plug it back in. So let's try our first angle, 8 cosine 154.3 plus the square root of 52. So that's scientific notation, very, very small, 0.002. It's not going to be exact because I rounded my angle. If we try the other one, 8 cos 205.7 plus the square root of 52. Once again, we get actually the exact same number, but still very small. Scientific notation means that's less than 1, so very close to 0, which is what I'm trying to get. Okay, so 4 is actually kind of like 1. We got to move all of our trig functions to one side, so let's bring them all to the left. So -3 cosine x minus 3 equals -5. Add the 3 to both sides. -3 cosine x equals -2. And then divide both sides by the -3. So the cosine of x is equal to 2/3. Probably want to leave it as the fraction, don't make it a decimal. So then when to solve, we use our inverse and the absolute value. So second, so the inverse cosine of 2/3 is, so my reference angle is 48.2 degrees. So for cosine being positive, that's either in quadrant 1 or quadrant 4. So remember, these rules are from the previous section. So in quadrant 1, it is just my reference angle, so 48.5. And the rule for quadrant 4 is 360 minus my reference angle. So that would be 311.8. So those would be my two solutions. All right, last one. So we'll bring our cosine across. So -5 cosine x plus 8 equals 8. So subtract the 8 across. -5 cosine x equals 0. Divide both sides by -5. Cosine x equals 0. So use your inverse trig function. So the inverse cosine of 0. So this would come out to be second cosine of 0, 90 degrees. Now, this is kind of a special case because 0 can't be signed, so we don't know whether cosine is positive or negative, but it shouldn't actually matter. So if we assume cosine is positive, it would have to be in 1 and 4, and the rule is quadrant 1 is the angle, and 4 is 360 minus the angle. So 270 degrees. However, if we flip it and assume that 0 is a negative number, that gives us quadrants 2 and quadrants 3. In quadrant 2, the rule is 180 minus reference, which would give me my 90 degrees back, the same thing as I had here. And in quadrant 3, it's 180 plus my reference, which would give me 270, the same thing I have here. So since 0 is not positive or negative, you can use either set of rules to get the same answer. Either way. That brings us to the end of the section.